Hi, my name is Colin Ryan, and this presentation is on exploiting Keyoptrix 2, Part 1. So to begin, we're going to start with network enumeration of our Keyoptrix 2 machine. And so we needed to find our Keyoptrix 2 IP address. So I was able to find this by running an Nmap scan of the IP addresses, and we discovered that our Keyoptrix 1 was 192.168.56.114. And so once we discovered our IP address, we could go into more scans to enumerate our target. And I started with our Nmap switch O scan, which is going to detect an operating system. And we can see through the screenshots, it was able to get some versions it was running. I also ran a service scan, which you can see on the left side here, to get more descriptive of the versions detected. And then the last network enumeration scan I chose to run was an intrusive scan. And that kind of gave us a more in-depth look at our Keyoptrix 2 machine. So now that we have completed our network enumeration, we're going to look at vulnerability analysis and mapping. We're going to use three tools here: Nikto, OWASP, and Nessus. And so Nikto is just an open source vulnerability scanner used to scan web servers to determine their vulnerabilities. This isn't always a stealthy scan and can lead to false positives. It is reliable though for intranet or in-house applications because it's not a quiet scan. And this also verifies server versions. Then we're going to look at Zap over here, and this is an open source software designed to detect the top threats determined by OWASP. And this sets up a proxy between servers and clients to identify all vulnerabilities in the web server traffic. It inspects and intercepts the messages between them. And this could also lead to some false positives as well. And then we have Nessus over here, and this is a security scanning tool used to uncover vulnerabilities and expose the architecture. This does not make assumptions on the server configuration. It tests each port to determine what services are running, and then it can test the service. This supports a wide range of OS and applications and can use on physical and virtual networks. It cannot be used, though, on a system with a host-based intrusion prevention system, though. First, we're going to look at utilizing Nikto. So really all we had to do was open Kali and run this on with the command listed below here. And it came up with a lot of information. I listed a few just examples right here, but it started listing vulnerabilities once the scan was completed. And same with OWASP. So we ran OWASP through Kali. All you have to do is enter the target IP address in there, which is listed in the screenshot. And then it came back with a lot of alerts, and it's going to tell you potential attacks, the risk level, and the possibility of attacks. You can also click on them and it'll go more in depth. And then last we have utilizing Nessus. So this was downloaded from Tenable, and you run it through the web and just perform a scan on the target IP address. And as we can see in the screenshot, I listed my scan with my last name in Keyoptrix 2, and this just uncovered more vulnerabilities and the severities listed as well. So now we're going to take a look at two types of cyber attacks that are relevant to this video, and this is cross-site request forgery. This attack forces end users to execute unwanted actions on a web application in which they are authenticated. If the user is authenticated, the site has no way to distinguish between a forged request or a legitimate request. And if the victim is a normal user, the attacker can perform change requests, but if they're an administrator, the entire web application has the potential to be compromised. So some mitigations for this would be Framework has built-in CSRF protection or double submit cookies, but really cross-site scripting can be used to defeat these mitigation techniques. And now we're going to look at cross-site scripting, which is an attack that injects malicious code into trusted websites. And an attacker uses a web application to send this code to an end user, which will then be executed because it thinks it's from a trusted source. And this allows Attacker to access sensitive information and retain browser information used in that trusted site. And some mitigation techniques would be to ensure all variables are validated and sanitized, output encoding, and then really have a modern web framework such as templating and auto escaping. So now that we discussed some types of attacks, we're going to look at the possible vulnerabilities we uncovered with all these vulnerability scans. So the first one, anti-clickjacking X-frame options header is not present. This means it can be vulnerable to clickjacking. Then we have XSS protection header not defined. This means it's at risk for a cross-site scripting attack. And then X content type options header not set. This is vulnerable as well to a cross-site scripting attack. And then our Apache version seems to be outdated, and we can exploit this just by Googling some exploits for this version. And then allowed HTTP methods, we have get, head, post, option, and trace. So options and trace is allowed, and this can increase the attack surface as well. And trace enables the entire HTTP request, so this makes it vulnerable to cross-site scripting as well. Some other possible vulnerabilities, SQL injection, as we saw from our OWASP ZAP vulnerability scan, and then we have absence of anti-CSRF tokens, so it's vulnerable to a CFR attack. Then server leaks information via X powered by HTTP response header fields. Attacker can identify framework and components that the web application is reliable on. PHP unsupported version detected. We see there's a very old version installed and the supported version is much newer. And CGI, generic SSI injection. So remote web server hosts CGI script failed to sanitize the request strings. This means it's vulnerable to an SSI injection. The attacker may be able to execute some arbitrary commands on the remote host. So once you uncover your vulnerabilities, you need to determine a root cause, and this can be done by a root cause analysis. And this is a method of investigating known problems and identifying the causes. So some techniques would be barrier, and this is examining pathways threats can take. Change, review any changes that may relate to your cybersecurity effectiveness and could have caused it. Failure mode and effects, review process and product failures. Fishbone, you want to display causes and the effects. Pareto, analyze selected actions or tasks to produce results. And then the why question. This is just a series of why questions until the root cause is determined. So how a vulnerability came to be, we're going to look at our vulnerability that our Apache just appears to be outdated. So a quick hypothesis, if Apache is outdated and the running version is vulnerable, then software and applications are not being monitored for updates or overlooked. And another possible cause could be IT doesn't have the resources. And some fixes around this would be to have a tool to search your versions and make sure they're all up to date and security patches are being deployed. So looking into the flawed hypothesis methodology, we saw our vulnerability that XSS protection header not defined. Well, if this protection header is not defined, then the website cannot control their XSS auditors, and it is at risk for a cross-site scripting attack. Now that our vulnerability analysis and mapping is done, here's some attack vectors that I would choose for this. So we saw it's very vulnerable to cross-site scripting attacks, SQL injection. Our Apache was outdated, and I found an exploit online that you can do a denial of service attack. Also our CSRF token, so we can use one of those attacks, and an SSI injection attack. And we're just going to take a quick look at the legal and ethical and industry standards with vulnerability disclosure. So all parties need to exchange data in a formal and consistent way. You need to avoid privacy violations, degradation of user experience, distribution, and destruction and manipulation of data. You need to provide a notification to the affected party when vulnerabilities are uncovered, and you must not publicly disclose any details of the vulnerability until it's remediated and you've received written authorization to do so. And this is a quick list of my references. Thank you for listening to my presentation.